percent water. Okay, they're high in water. Itty bitty baby begins to grow, all right? And then as they begin to grow, and then, we start getting, toddler and up and up and up. And when they start to talking and be like, I love this one. Can I have a treat? Can I have a treat? I'm hungry. You just ate. Yeah, but I'm hungry. Seriously? I mean, my grandchildren, it was so funny, as they were coming up, and I'd be like over babysitting them or whatever, and they would be like, can we have a snack? Can we have a snack? Can we have a snack? And and their mom was like, okay, they get to have their breakfast at this time, lunch at this time, dinner at this time, snack at this time, snack at this time, snack at that time. And boy, when they were younger, whew, man, it was tough because they wanted to eat all the time. And now, they're 11 and 13, they still like to eat, okay? And, it's just a little more control. But this is why, as a child, as the itty bitty baby to the child until roughly adult, okay, all the bones in their body are making red blood cells. All of them. Once we reach adulthood, roughly about 18, 19 for females, about 22 to 25 for males, it then becomes certain bones of the body. So yeah, their bodies were busy. They needed the fuel because they were making these cells. In that bone marrow, they were giving rise to all of those formed elements. This is called bone marrow, that tissue in the bone. We call it myeloid hemopoiesis because it is the production, okay? Now, these other cells, one of the things about, for example, those white blood cells, the ones that we think of with the immune system, well, they're going to get produced in the bone marrow, but they have to go somewhere else in the body. For example, they have to go to our thymus gland. Do you guys remember that from the endocrine system? Now, baby, child, adult, what has happened to that thymus gland? It shrinks. In the baby, child, preteen, teen, okay, when we say, as the child, huge, I'm talking huge, okay? Me right now, very small. You guys, small, okay? Because those cells that were getting produced had to go to that thymus gland, get exposed to the protein, become T cells that will go to our immune system tissues, a lot of them to the lymph nodes, so that they can be used. B cells, which are going to be from bone marrow, all right, once again, they'll get produced, but they don't have to go to the thymus gland. They just simply go to stuff like our lymph nodes, all right? And their job is help produce the white blood cells that are going to help the body fight something when we get exposed to it. And that happens a lot from the time of birth until adulthood. And remember, throughout that time frame, they're getting vaccinations, they're getting exposed. We're getting, hopefully, what we know as our immunity. The production of the red blood cells, well, that just continues and continues and continues and continues. Because we're doing that all day long. White blood cells are getting produced also, but as we get older, become an adult, it's just not that great I mean, it's a good size production, okay? But hopefully we've built up a lot of our immunity. All right? So that's one of the reasons that children are hungry. They're busy. Their bodies are busy. So, how do we get it? Everybody in here is familiar with stem cells, right? What's your understanding of a stem cell? I can make it into something else. Why? When egg and sperm meet and fertilization occurs, for that embryo to begin, once those two cells have met, what begins to form are stem cells. And the proper development of that embryo to a fetus, to an offspring, becomes the job of being dependent upon chemicals. It is dependent upon chemicals from the mother's body, and then as the embryo itself continues to develop other chemicals to become that fully formed offspring. A stem cell is one that has not received the chemicals yet. So if you have a true stem cell and you expose it to the chemicals that should develop into A or B or C or whatever it is, it should give rise to that. Does that make sense? So for our blood cells, note I'm saying blood cells, red, white platelets, okay? I have a stem cell. It is termed the hemopoietic stem cell. And from that one cell, I will get my lymphocytes, my red blood cells, megakaryocytes, which are my platelets, basophils, eosinophils, neutrophils, monocytes. The way that it does it, do you see this little intermediate right here? Okay? That's called a colony. So note that the one big stem cell gives me some colonies. It gives me a lymphocyte colony and a monocyte colony. Does everybody see that? And from my lymphocyte colony, I will get lymphocytes, T cells, B cells. That's it. Everything else will come from my monocyte colony. So when my stem cell, and it's working all the time, okay? So my stem cell is going to be the origin. Now, we can call it multipotent, pluripotent, but what it's going to do is give us these colony formings. From there, we're going to get these elements of the blood. And so far as the blood plasma itself, the blood plasma gets its components from our digestive tract, because that is a watery component of this connective tissue. So the plasma is dependent on our nutrients we take in. But the actual formed elements, red blood cells, white blood cells, platelets, come from a stem cell. Lots of work, lots of research is done with stem cells now. I am all for stem cell research. I think they should do everything they can with it. I don't know if y'all are familiar with stem cell research, but it's very life-saving, very life-saving. And so stem cell research, we'll stop right there, but stem cell research is similar to that. They've actually learned how to recover some of these bone marrow cells and help address some of the medical issues they face, like certain cancers and so forth. Any questions? All right, take a break. Be back at 1:45.